Hello teacher, my name is Thai Khotiam. My name is Ping in Chemical Process of Engineering. Today gonna talk in two parts. First is volume by series animations and volume by cylindrical shells. And the first is 2.1. It's about the area in number of measure in two-dimension regions. Volume in number of measure in three-dimension regions is 2 or 3. It can be computed multiply length, width, and height is V ท่ากับ V equal LWH. The formula for the volume of spheres is V equal 3 equal 3 pi r square. Yes, and the formula is important is V equal pi r square h, and the last formula is very important is V equal eh, and this is three formula is important. So this is 3 dimensions cylinders, and this is 2 dimensions causeries. So 3 dimensions is causery in particular cylinder is identical to this other. If solids must have constant causeries and it is not one or the other basic solids, we may not have formula for its volume. Okay, it's not a formula. And the next is a solid with a varying causeries. We want to divide S into the sides and perpendicular and x-axis. As we can later in chapter, we may be time when we want to series the series in some other direction says with the perpendicular the y-axis, because causeries area is not constant. It's not constant. Replace the area of causeries as pi x. Now let's p equal x0, x1 to the xn. By regular a and b, and for I is 1 to n. This is repeated the series of existing from xi minus x1 to xi. To the following features show the solid within equal 3. So we have S1, S2, and S3. A equal x0 and x1, x2, and b equal x3. From the figure 2.13, the solid S has been divided into 3 sides perpendicular to x-axis. Finally, for I equal 1 to n, basic IB applied point is xi minus 1 and xi. Then the volume we get formula is V as about sigma I whole 1 to n a by a summation this. This is formula for equation pi in this y square. So we take pi. So we take square into r and y. Pi no sorry, we put y equal this. And square. Then we get okay. So we got integral 0 to h, and we equal pi r square multiplied by h over 3, and this final formula is like this. So it's equal to this formula. And next is 2 pi 2 volume by cylindrical shell. Okay, it's have two equation is important. Volume by zero shells. Okay. The first equation is this 2 pi h f(h). Okay, we focus on this. And the next equation is important, is 2 pi y dy. Why is have two equations? Because pi x and pi dy is not equal. It's the same features. So we're gonna look at solution. First, we must graph two regions R and assert this series of relations as shown in the following. Okay, first we must graph the regions R and their associated series of relations as shown in the following. The features. Let's have two features. Okay, A and B. A is the regions are under the graph of fx and series 1 over x over the integral 1 to 3. B, the series of revolutions generated while revolving are about y-axis. Okay, B is about y-axis. It's called 1 to 3 because the graph is 1 to 3. Then the volume of the surface is given by V equal A to B. Okay, this V equals A to B and 2 pi f x dx. This is first step. And next step, we know A equal 1 and we know A equal 1 and B equal 3 from this graph. A equal 1 and B equal 3. So the y-axis we fix from figure 2, y is 1 over x. So we get like this. So the final answer is 4 pi squared 3. Thank you, teachers. Okay, and next equation is V is equal limits, and the last equation is is integrals a to b is ax by dx. Okay, this important equation. So the technique we have just described is called is Cylindrical method. To apply, we use following staging. Okay, we see the features A and feature B. It has 3 dimensions and it is 2 dimensions. A is a pyramid with a square base in oriented along the x-axis. B equal a 2-dimensional view of pyramid is seen from the side. We want to determine the shape of a convex of pyramid. We all know the base is a square, so the convex are square as well. Step 1. Now we want to determine a formula for area of 3 constellation square. Look at the figure 2. Okay, so we get equation like this. Is a equal 8 divided by h. So this is important equation. And we can find AH to push on this. This is formula. Okay. We is equal integrate a b a x b x. So and next we find ax. This because we want to input on the equation pi. So we take square into r and y. Pi. No, sorry, we put ry equal this. And square. Then we get okay. So we what integral 0 to h, and we equal pi r square multiplied by h over 3, and this final formula is like this. So it's equal to this formula. And next is 2 pi 2 volume by cylindrical shell. Okay, it's have two equation is important. Volume by cylindrical shells. Okay. The first equation is this 2 pi x fx. Okay, we focus on this. And the next equation is important, is 2 pi y dy. Why is have two equations? Because pi x and pi dy is not equal. It's the same features. So we're gonna look at solution. First, we must graph two regions I and assert this series of relations as shown in the following. Okay. First, we must graph the regions R and their associated series of relations as shown in the following. The figures.